Are you someone looking for a job as data engineer, analyst, or architect on cloud, but struggling to crack interviews because you're not confident enough with some of the topics often asked in interviews? In this video, we'll dive into one such important topic, loading data into a data warehouse on cloud. Also, this video is part of a free Data on Azure live masterclass where we share a proven 3-step framework that has already helped over 45,000 people like Simran, Hari, and Ankita get certified and land high-paying jobs in Azure Data. So don't miss out on this opportunity. Click the link in the description below to register and take the next step.
Let's get started by creating a workspace. So I'm going to go to the workspaces and say I want a new workspace, and let's give it a name, class 07 workspace, and we will make sure that it is attached to the trial or to the fabric capacity. We don't have the fabric capacity, so we'll attach it to the trial. Large semantic model, we don't need it at the moment. If the semantic model increases beyond 10 gigabytes, then we have to select this option. In real world, you will select this option if your uh, semantic model size is beyond 10 gigabytes. We will go with this and then simply say apply. So here we have our workspace. Now, it is always a best practice that before you load your data into the warehouse, you stage it into a lakehouse so that you do not have to go back to the original source of the data if something goes wrong. Otherwise, it can create what is called a source contention. If you or any other data engineers, they go to the same source at the same time, or they go to the same source more than one time, it can create something called as a source contention, right? Lot of ETL pipelines are trying to connect to the same source very frequently and more than once. So it can create something called as a source contention on the source system. And obviously we will never get luxury that you are allowed to connect to the source as many times as you wish. It is only periodic that we will get access to the source system. So imagine a source system is a SQL Server database, transactional system, OLTP system, and it has, let us say, some secondary readable replicas. So we will only get access to those secondary readable replicas maybe during the time when the production workload on those replicas are very low, maybe in the nightly hours or something like that. So it is not on demand that I want access to your SQL Server OLTP system, please give me the access. They say right now it is a production time, and we are doing e-commerce, right? It is doing 1,000 transactions every second. We're not going to give you access. So we should always stage before we load it into the warehouse so that we don't have to go to the original source more than once, right? It can create unnecessary source contention. So let's quickly go and create a lakehouse first, because we will require a lakehouse for staging. So I say a lakehouse, and let me give it name, right? So we can say staging lakehouse, that we are planning to use it for staging purposes. Staging lakehouse, create. Now, the source of data. Where is the source of your data, right? So source of the data can be anything, right? So if you were to upload files manually, the source becomes your laptop or a desktop. If you run a pipeline, the source becomes those 1,000 connectors that you have, or a Dataflow Gen 2. They all have so many different connectors that you know, right? So what we're going to do is that we're going to run a pipeline the way we're going to run it in real world. Uploading files is also possible. If you have local files, let's say you have 1,000 CSV files locally in a folder, you can upload that, okay? Uh, or even shortcut is a possibility, right? So if your data is in any of these places, in some other fabric tenant, right? Cross tenant is allowed, right? So if it is in other fabric tenant or your own fabric tenant, right? Internal Microsoft OneLake tenant. But most probably you will go for Amazon S3 bucket or ADLS Gen 2 or Google's cloud storage shortcuts, right? So this we have seen already how to create a shortcut. We're going to quickly do a pipeline, right? So I will say, hey, I would like to move the data via the pipeline. So I'm going to say that this is our staging pipeline. This is the pipeline that will go and connect to the original data source and bring the data to the staging lakehouse. And once that is done, then it is our freedom what we want to do with that data. Right? So here we go. So here it is, right? So this is opening the wizard. So we can take the help of the wizard, or you know that you can do it manually also. If you want to do it manually, let me cancel this. Let's say yes, cancel. Then you're going to say add to the canvas the copy activity, and now you can configure the copy activity. Okay. Or if you wish to do it via the wizard, you can open the copy assistant and do it via the wizard. Up to you. How do you want to do it? All of these are the connectors that are possible, right? So let's quickly do it. Okay, so I will select over here HTTP, this one, right? So my data is located on the GitHub server, right? So I'm taking the same scenario which we have already seen earlier. In your real world scenarios, it can be a SQL server, it can be an Azure SQL DB, it can be Amazon S3 bucket, or whatever it is, right? Create a new connection name. Let me give it a small connection name, sales GitHub. Okay. Gateway required, no. Anonymously visible. This data is anonymously available. There is no requirement to do any kind of authentication on it. So next. Okay. Relative URL not required. Request method is a get. Additional headers, binary copy, request timeout, not required. Move ahead. It will auto identify what is the format, right? Says it's a delimited text and comma separated. Row delimiters are carriage return line feeds. Next. Yeah, it's loading. So let's quickly preview if everything is working fine. Yeah, back. So detect the text format, detecting it automatically. Wonderful. First row as a header, preview the data. Wonderfully fine, right? Everything is getting parsed properly. Schema is also detected. Okay, so all columns it is taking as a string. No problem, no worries on that front. So here we go. Next. Where is your destination? Where do you wish to keep it, right? So I want to keep it under my staging lake house. Under the files, we can do it under the delta table also, right? That will become bronze delta table, right? I would take it to the bronze delta table. Okay, I would prefer to take it to the bronze delta table if I want to do medallion architecture. But obviously, right now, what I want to do is that I want to take this file directly to the warehouse. You can take it to the warehouse via the Medallion architecture also, right? That is up to you. That is your architectural design. What do you want to do? I'm going to take it under the files. So I will say browse. Where do you want to keep it? In the root folder itself. Right, that's it. Root folder itself, we're going to keep it under the root folder itself. We can give it a name, sales.csv. Copy behavior, flatten the hierarchy. It's not a JSON file, so that's not needed. More than one file, merge files, not required. Preserve the hierarchy as it is, copy the JSON. So it's a CSV, we don't need anything of this sorts also. So this is done, so we can now go ahead and say next. Delimited comma, add header to the file, no compression. Next. So start the data transfer immediately. So we are connecting to the source system and we are trying to move it to the file section as it is, right? In the CSV format, whatever the original format is, I'm just bringing it into the original format in my files. It's just bronze, right? This is nothing but bronze file. You could have taken it into directly to the bronze delta table also, but that would be if you want to do some medallion on it, right? You want to do medallion architecture on it. That's why we will take it to the bronze delta table, right? You can directly take it to the bronze, or you can copy it into the first into the bronze files and then take it to the bronze delta. I hope that point is clear. Those are all design decisions, right? We want to keep the original file as it is in the CSV format, so let's keep it first into the files. Then we always have the luxury to convert it into a bronze delta table, isn't it? Right? So we are taking it to the files and let's say save and run. And here it goes. Starting, successfully running the pipeline. Let's wait for this to finish. And it seems it is almost completed. Perfect. We could have directly taken it to the delta bronze table, or we could write it to the files. I'm writing it to the files because now I have the luxury to convert it into the delta. That is quite possible, right? So now what I'm going to say is that I want to convert it into the bronze delta. We could have done it directly also, by the way, right? So let's go back to the lake house. We would have gotten our file, right? Refresh the page. Yeah, here it is, sales.csv. Right? So our pipeline is responsible to do this movement. We can schedule it, we can run it on events, right? All of those things can be done. We can add a schedule to it, we can add other kinds of triggers to it, right? Event-based triggers are also selected, okay? Event-based triggers are only blob-based triggers. These are called as event grids, right? Grid-based triggers, okay? So all of this can be done, okay? If you need any assistance in any of these, please feel free to uh, see it in the WhatsApp chat. So this is done, right? So this part is done. So which means we will get our data in the bronze section. This is bronze. We have not created a folder, but this is bronze. You just took as it is the data from the source and you just copied it as it is into your lake house. So this is bronze. Okay. Let me convert it into bronze delta because this is now our freedom. We can do it. Okay. So let's convert it into bronze delta. So I'm going to say new table under DBO, right? And let's give it a name, staging sales. So staging underscore sales. Use header for the column name, separator is a comma, and let's load it into the bronze delta. So bronze file and now the bronze delta. So here we go. We load it into the bronze delta. So this is the process of staging part. Data from the external world has been brought as a delta table in the lake house. So this now acts as a staging layer. Why did we do staging? Because if something goes wrong in my warehouse or my movement to the warehouse is not happening properly, something wrong happens in my ETL pipeline, I always will have a luxury to now take the data from here rather than running this pipeline again. Because if I run this pipeline again, it will go to the source system and connect to the source system again, which would unnecessarily create source contention. It is like going to the same person again and again and asking the same question, right? So that person will get annoyed. Why are you coming again and again, right? So we do not want source contention because in a real world, your source will have production workload running on it. Imagine a CRM system, imagine a transactional OLTP system, imagine any other source where a lot of production grade workload, enterprise grade workload is already running. So they're not going to give us any time that you come and you connect and you take the data. When the production workload will be very low, then we will be allowed to run our ETL pipelines. Okay. So we don't want to create unnecessary source contention. So the best practice is always let the pipeline move it once to the staging layer first. So now we have it in the staging layer, right? So now if you want to do Medallion on it, you can do Medallion on it, refine it even further, right? I'm skipping that part, right? I'm skipping that part. Okay, I'm skipping that part. I'm not doing any significant Medallion on it. I believe that this is already clean, ready to be punched into the warehouse. In real world, we will have to carry out Medallion on it. Please understand this point. A bronze table is not meant to be directly uploaded to the warehouses. It does not happen in the real world. Will rarely happen, right? So the bronze table directly cannot be taken to the warehouse. So you're going to be loading it to the your Delta API using Spark cluster or using data frame API and then do your batch medallion on it. We have discussed it already. Batch medallion on it. Then we are ready to take silver tables to the warehouse. So it is really the silver tables that should be taken to the warehouse. But since we are just discussing the concept over here of uploading the data, that's why I'm taking the bronze table directly to the warehouse, because that's what your lab tells you to do, right? It says, let's take this bronze table to the warehouse. But in a real world project scenario, I am creating a project for all of you. You can try that project. I am authoring that project, right? In that project, you will see that we will never tell you that you take a bronze table to the warehouse. That does not happen. You have to take silver tables or gold tables to the warehouse. But let's proceed, right? So what we're going to do is what we're going to now do is we're going to say that we want a warehouse. So we'll go back to the workspace and say, give me a warehouse, a parallel PDW machine, parallel data warehouse. So I say, give me a warehouse, clean, structured SQL warehouse. So let us give it a name. We will say it is sales warehouse or DWH, PDWH, PDWH, so that you can understand that this is not a lake house. It is a warehouse with historical context of the data, and it's a massively parallel system to run petabyte scale queries. Okay, so let's create. And here we have our warehouse. So our warehouse is ready. The warehouse is sales PDWH, sales parallel data warehouse. So now what we're going to do, obviously, is to create the empty table structures, because the data will be loaded in those empty table structures. Although there is a statement which is called a CTAS statement, where you do not need to create the table first. It can directly be created. We will come to it, right? But let's look at the general scenario. What most of the data engineers will do, they will first create the empty tables and then populate those tables appropriately, okay, from the staging layer. So let me keep the staging layer open. So I will just duplicate this, duplicate. Here is the staging layer. So this is our staging layer. And the staging layer is getting filled from the pipeline layer, right? So this pipeline layer is filling the staging layer, right? You can run this pipeline on schedule every 7 days in the weeknight, every 7 days in the nightly hours, right? So we can run this pipeline every 7 days in the nightly hours, right? So, and that fills up this space, okay? And now we are ready to populate our warehouse. So what we're going to do is, here is our warehouse, and I'm going to say I want to create a new schema first of all. And the schema will be, the name of the schema will be, I will create a schema sales. You know why we create schema? We create a schema in order to differentiate the name. US dot customer table is different from Europe dot customer table. So we will first create two schema, US and Europe, and then create the tables, right? So let's create over here the schema done. So we can now close this one. So now everything we're going to do under this sales schema: tables, views, user defined functions, stored procs, user defined stored procedures. It is always better to do the inserts into the table via the stored proc, right? So let us see how do we do it, right? Let's first of all create a table, right? So I will now open over here a new SQL query and say I want to create an empty table. I want to create an empty table, right? So create schema is done. I want to create an empty table. If not exists, select the name of this table from sys.tables and schema name sales. If it does not exist, then create it. Obviously, it does not exist. We have not created it yet. If you have created it, it will obviously be existing. It will not create it then. So you can see create table sales.fact sales, customer ID, item ID, sales order number, sales order line number, order date, quantity, tax amount, unit price, right? And these are the column data types. So let's create this empty table. So this is a DDL statement, data definition language statement. We are defining the table, DDL statement. Let's do this very quickly. Run. So the fact sales is done. It's empty, right? This table is totally empty. You can try to query it. It will obviously give you nothing, right? It is empty at the moment. Empty. That's it. But what kind of a table it is? If you were to look at its properties, you'll find that it's a delta table, which means it does not store the data in MDF format, does not store transaction logs in LDF format. It is not using proprietary Microsoft private format. It is using an open format delta, right? Which is great. And here are the places where it is kept in the real world, which means it is in the lake. It is in the one lake, right? It is in one lake. It's sitting in the one lake. Okay. So here we go. So one table is created. Let's create few more tables. So let's create dimension customer. So here I do dimension customer for you. Dimension customer, customer ID, customer name, and email address of the customer. Right? So let's create one more table. Run. Empty table created. Again, it is a DDL statement only. So this is the data definition language statement. We are defining an empty table. Okay. Let's do, first of all, another table, right? So we're going to do one more table, and the table is the item table. Two dimensions, one fact. So another table, dim item, and it has item ID, item name. So now run this table. Done. Now we would like to make sure that in dim customer and dim item, you do not create duplicate entries for the same customer. You should not create duplicate entries for the same customer. How to do that? How to make sure that you do not create duplicate entries for the same customer? We need to place a constraint on the customer ID column that this customer ID column must be a primary key without any clustered index on it. Right? Yeah. Distinct and not null. So we want to make sure that this customer ID column and this item ID column must be distinct and not null. So the way to do that is to, add just a constraint. So we will say that customer ID column, alter the table. So alter table, dim customer, add a constraint, name of the constraint, type of the constraint, primary key with a non-clustered index on the customer ID, not enforced, right? Not enforced. And go. Let's try this out. Done, right? So here we can see that we just added the constraint on the dim customer column, right? So this column now will essentially be unique, distinct, and not null, right? Because there is now a primary key sitting on it, and we have not created a clustered index on this. We don't want to sort it on customer ID, right? We don't want to sort it on customer ID. You will create a clustered index if you would like to sort it on the customer ID, right? If you would like to sort it in the physical order of customer ID, we don't want to do anything of that. And why would I need a customer ID to be used as a sorting condition, right? Non-clustered will help us to use this in filter clauses, right? Primary key by default creates a clustered index if you leave it, but it's not mandatory that the primary key should always have the clustered index. We can set it to be non-clustered index as well, right? So here we go. We will add another alter table, and we will say that alter table, and here we go. One more constraint is what we will add. This constraint is for the dim item, that you do not insert duplicate items. So please make sure that primary key is created on the item ID with a non-clustered index on it. Okay. And here we go. Run. Finish. Right. So now all our empty tables are done, right? So this is all DDL, which we did. right? So this is all DTL that we have done. So what we can now do is that we can now close this, or we can keep it, no problem. Now what should we do? What do you think? The best way of loading these tables in the warehouse from the staging layer is to have a view on the staging layer created over here. Why? Because you know that if the underlying data changes here, the view will automatically change itself, isn't it? The view will automatically change itself, because view essentially means it will auto update itself once the underlying table's data change. So the best strategy is that directly not take the data from here and put it here. It would be better to create a view first of all. So let us say I want to do a view now. So I'm going to say, hey, I want to do a view. I would not directly upload it into my tables. I would like to create a view. This is the best strategy. Create view as select. So create view in the sales under over here. Name of that view is sales staging. And where is it created on top of which? It is created on top of the staging layer of the lake house. So the name of the lake house is a staging lake house dot dbo dot staging sales. So we will now just put the name of our lake house over here. That I want to create a view on top of this lake house. Why? Because it's the best strategy. It can even then be used in stored procedures, right? So here we can run this thing, creating the view. Now the view is ready. CVAS statement. This is called as CVAS statement. CVAS statement. Do you know that instead of doing anything like this empty table creation, we could have directly created create table as select, but that's not the best strategy. Create table. Instead of a view, create a table, right? Create a table, sales dot, let's say staging sales, demo direct. I'm just giving it a name, right? So this is called a CTAS statement, create table as select statement. You can do this also directly, but this is not recommended. Because if the data in the underlying table changes, you will have to insert into this table again. But this does what? It does DDL and DML together. Why? Because it will create this table and then it will also insert the data from here into this table. So it is DDL plus DML. DDL plus DML together. Data definition language plus data manipulation language together. Because creating the table is DDL, inserting the data into that table is DML. Within a single statement, we will be able to do. Like if I were to run this for you, you see, it will create this table directly for you. Done, right? Directly from the lakehouse staging layer, directly from the staging lakehouse to the warehouse. So it can create the table for you. Something like this, staging sales demo direct, but this is not recommended. Yeah, we can drop the table, recreate it. That's all improvisations, right? Improvisations. We created one on dim item and dim customer. Two different tables, the constraints were created. We created the constraint on the two different tables, right? We created the constraints on two different tables. Okay. We'll come to this. What is this not enforced very shortly from now, right? In a data warehouse, performance is what is more important than enforcing the constraints, right? So if you see, there is a small note that is added after placing the constraints, right? Something like this. So this is the note to remember. In a data warehouse, foreign key constraints or primary key constraints are not always necessary. They can help ensure data integrity, but they will add overhead to the ETL process and slow the data loading process. So it's a very careful consideration. So when we add any constraints in a warehouse, we give a warehouse the luxury that it is not mandatorily enforced. if you believe that it could hamper the performance of the petabyte scale queries, what do you want? If I run a report, I'm a CEO, and I want to run the report on, say, 100 terabytes of data, which is in the tables in my warehouse. Do you want the report to furnish fast, or do you want foreign key and primary key constraints to be taken care of? You want queries to run faster. Bring your data and insert your data into these tables, making sure that it does not have duplicacy. That you have to do beforehand. That's called as pushing the transformation upstream. Pushing the transformation upstream. That is, yes, it's quite possible that someone may insert duplicate data into this table. That's why we are saying that you should add this kind of a constraint that this key will be primary, not null and distinct. But that is not enforced always, because we will give the room to the warehouse to optimize the performance. We will make sure from our end as much as possible that what we insert in this is not duplicate. That is, we will push the transformation upstream. Okay, that's the whole idea. So see, this table was created directly, but we want to create a view. So you see, now the view is ready. So this view is what we now going to use in stored procedures. That from this view, which does not have any data, view does not have any data. So this view, which is created on this layer, via this view, we will be now loading these tables, that too via the stored procedures. The best possible way, right? So now let me open another query, new query, create. Let's do one more query now. So what we're going to do, I will say from this view, which does not have any data, it will go and take the data from here. From this view, I want to load these tables. But how? How I am going to do? One way is to do insert into select from. So one way would be insert into dim customer. Okay, dim customer. Insert into insert into sales dot dim customer. Insert into sales dot dim customer. Insert into select from. Select from. Select star from the view. So we can say sales dot staging sales, this thing. So what columns do you want from this? Do you want all the columns? No, I only want customer ID. So where is customer ID here? Is there any customer ID here? No. So in this, there is no customer ID in the view, right? Is there any customer ID here? I don't see any customer ID. So looks like that person, we will have to furnish the customer ID ourselves. Okay. So that we will do, we'll see how to do it. But customer name is available, right? So I can say I only want customer name, and I want what? Email address in this. So email address here is there and email address here is there. So I can say, okay, you give me the email address, and I will figure out what customer ID to put over here, right? So I can do that, right? Customer name plus some value, okay, to make it unique, random value. So insert into select from is possible, right? Insert into select from. You just need to select the ID. Directly the ID is not there for customer here. So we will have to create artificial ID over here. Maybe customer name plus some random number. Okay. It is better to be done in the stored procedure, not here. Because there we can give integer to every row that we are inserting here. So insert into select from is not the right strategy. Believe me. One of the option is, so let me just say options. Option number one is insert into table select from view. This is one of the way of doing it. But the right way would be that whatever is in this view, you insert into the table via the stored procedure, via stored proc. So now we're going to be creating a stored procedures to load data into the warehouse. So here we go, and I'm going to define stored procedure to load the data into all the three tables appropriately. What a wonderful data engineering, right? That you do it via the stored proc. So create or alter a stored procedure. See, order year integer, right? Order year integer, which means when you execute this stored procedure, you will be able to say data of which year do I want to insert, because it's quite possible that it may have data of more than 1 year. Okay. So let's go how we do it. So insert into sales.dimension customer in the column customer ID, customer name, email address, select distinct. So did see what we did? I am before inserting data into this table, before inserting, I am making sure I select distinct from the view. So select distinct customer name, email address. So see, we are using customer name as the ID of that. It's not a good thing to do, right? Customer ID plus some random number. So for customer ID, I am also using customer name. This is not good, right? But no problem, we can do it. Okay. Select distinct customer name for customer ID, customer name for customer name, email address for email address. It would have been better if we would have used some random number over here. Okay, random identifier. But nonetheless, from the sales dot staging, this thing, this is the view. Okay, this is from the view where year of the order date column is the order year and not exists anything of this. Select one from this where the customer name is matching the customer name and email address is matching the email address. So this is the way to make sure that we don't enter any duplicate column. No duplicacy should be there, right? Which means only insert what is not there in staging sales and in customer ID. Something which is already there in customer ID, don't insert it again. That's what it says. Don't insert, do not, do not insert customers who are already there in this table, dim customer table. If the customer is already there in the dim customer table, then this will return 1. Why? Because it will find that the customer name in the dim customer is matching the customer name in the staging sales, which means the view has that customer which is already there in the dim customer. I don't want to do that, right? And not exist, right? So this will make sure that we are not inserting duplicate entries over here. Similarly for here, sales.dim item, item ID, item name, select distinct item from sales.staging sales from the view order, and there should be no duplicate entry. And similarly, insert into sales fact into these columns. All of this data, some casts are also used because you know that here everything is string. Okay. So they are just casting it into a proper data type, and that is it. You cast it and then insert. So let's run this stored procedure. Create this stored procedure created. So now we have our stored proc. So I just now need to run this stored procedure periodically. That's the whole idea. I just need to run this stored proc periodically. Okay, I just need to run this stored procedure periodically. So how to do this? How to run this stored procedure periodically? Let's first run it manually, right? So let us first of all see that these tables are currently empty. This table is empty. Dimension customer is empty. Dimension item is empty. And the fact is empty. Fact is empty. All the three are empty. So they will be populated via this view, via the stored procedure. So I have to execute this stored procedure, which will take the data from here. This will take the data from the original source because it is the view. So from this delta table of ours, the view gonna take the data, give it to the stored procedure will put it into these tables. Currently they are empty. So now we are ready to run that stored proc. So let's run that stored proc manually. Okay, so let us run this stored procedure to insert the data of the year 2021 only. So here I say, I want to execute this execute this load for the year 2021. So from here, I just want you, so let's say, take me to the SQL Analytics endpoint, show me the data of this table, how many years data it has, right? Table, staging sales, new SQL query, select top 100, right? So it looks like it has the 2021, it has other years as well, right? It would have the other years as well, right? Distinct year part of the order date, right? So I could say just give me year part of the order date. Remove all of this. Select distinct year part of the order date from this table. Just tell me how many distinct years I have in this data. 19, 21, 2020. Data is of the 3 years here, but I want to only insert the data of a single year. Let's do it, right? So I want to execute to 2021. Run. Load started. It is loading from the bronze delta table. It should be a silver delta table, but no problem. We are loading from the bronze delta table into our warehouse. Done. So let's see. Is the dimension customer loaded? Dimension customer. Is the dimension item loaded? Dimension item. Is the fact sales loaded? Fact sales is loaded. All the three are loaded.
Thanks for watching. If you found this video helpful, don't forget to hit that subscribe button for more valuable content like this. Also, don't forget about our free Data on Azure live masterclass. The registration link is in the description below. It's a great opportunity to get certified and boost your career in Azure Data. So if you enjoyed this video, make sure you watch the previous video on DP700 series right over here.